think that wetlands are areas that you can't farm. So traditionally what would happen is you would drain the wetlands in order to increase your surface area for farming. So bad name in the sense that to increase your, I guess, hectares of farmable land, then the first thing you'll do is reduce the percentage of your land that is in wetlands. So by doing that, you've taken away the ecological value of those systems. So we've kind of hit a tipping point where we have converted more of our wetland area on like in Ontario or nationally or internationally, such that the ecosystem can no longer process the excess nutrients that we're producing. If you have any solids coming off, so that could be from erosion from fields, so just solid particles, or if you've got runoff from manure piles, which have a lot of solids in them, those would be two cases where a settling pond as a first step would be very, very effective and doesn't need to take up a lot of space. So there you're going to basically physically settle out the solid matter, and that contains a vast majority of the nutrients that are moving off farms. So we can capture at a farm scale at basically the drainage outlet of the farm, or if you have a manure pile, then wherever that the drainage point for that manure pile or a loafing pad is, you can then remove maybe upwards of 80% of the nutrients because they're attached to the solids. They're going to fill up the sediment in the bottom of your pond, and then you can excavate that with the backhoe maybe once every 10 years and just put it back onto your fields as nutrients. So that's the most effective, I think, option right there would help address the contaminant movement in terms of nutrients from a lot of the farming landscape. And that's for the solid. So now if you're talking about the soluble forms, so soluble phosphorus and mostly nitrate would be the soluble form of nitrogen, then that's a slower process and takes more surface area. So it's equally feasible in terms of wetlands. The wetlands process nutrients very effectively. You can reduce them, however, you'll need to have a larger surface area, again, at the outlet of where your water is exiting your farmstead. So those would be your two options. In both cases, you'll have to allocate a certain amount of land, but if it's just a settling pond, that is very small compared to your operation. If you're looking at reducing soluble nutrients, then you're looking at shallow wetland cells full of native wetland species, so cattails and reeds. That'll take up a little more space. So there's different mechanisms. So as I said earlier, the first mechanism is just settling. So anything that's solid, very effective at removing solids, just any pond or wetland cell. So if you have erosion, soil coming off your farm, and any particulate matter that has nutrients attached to it, then settling is the first mechanism. After that, then we have the dissolved species. A certain percentage of them will be taken up by the plants. They'll be used by the plants themselves. Part of that will be released at the end of the season when the plants die off. Part of the nutrients go into the roots. They come back up in the spring for the regrowth. You stock a certain percent. So that is one mechanism that is long lasting. The amount of accretion of decaying plant matter on the bottom of your wetland cell will trap nutrients for the long term. The other mechanisms then for phosphorus, it absorbs to any site in the soil that has a positive charge to it. So any iron, aluminum, calcium, magnesium in the soil will absorb or precipitate phosphate molecules. So that's a physical or a chemical mechanism that occurs based on the soil type, basically. And we're actually researching to see if there's absorption into the dead plant matter. So as you have this increase of sediment from the old plants, one of our hypotheses in the research we're doing is that there's a certain amount of absorption going on that will continue year after year as you add more dead plant matter. So if this is true, then that's another mechanism that will be long lasting for the removal of dissolved phosphorus. So those are the main ones for phosphorus. For nitrogen, it's mostly nitrate is the runoff from agricultural fields. and or drainage from tile drain systems. And wetlands can be very effective at creating the situation or the conditions whereby bacteria that are naturally existing in the sediment take the nitrate molecule and convert it back into N2 gas. And then we just return nitrogen to the atmosphere where it's supposed to be, right? And basically what humans have done on a global scale is we've taken nitrogen out of the atmosphere, we've turned it into fertilizer, and we've increased our agricultural production. And that's why the population on the planet is what it is, because we can support that growth. But the negative to that is we've got twice as much nitrogen in the form of mostly nitrate in our water bodies as is naturally produced in the world. We've doubled it. So we have to take all that nitrogen and put it back into the atmosphere. So that is the challenge. Wetlands are pretty effective if they're designed properly and you have enough retention time and there's enough sediment. So those conditions where you've got zones which have less oxygen and a source of carbon from the decaying plant matter, they're very effective with the microbes that live there to convert nitrate into N2 gas. Yeah, so they're very inexpensive to build. We're talking about basically surface flow wetlands for the most part. So these are like you're constructing a natural marsh. So you need to have some excavator time. You want to compact the native soil. You would actually use a liner for these natural systems because you're just dealing with runoff and it's not as regulated as other waste streams. So really we're talking about excavation, compaction, perhaps planting, although even if you don't plant, the wetland plants will develop by themselves just from the seed base that naturally exists. So really the costs are very low to build a wetland cell. The larger cost is in the lost land for agriculture. So that's the more balance, I guess, from the farmer's perspective. So if there is land that is already low lying and has less yields, then it might be more opportune to allocate that for a wetland cell. The benefit accrues more to society in general. So you're not going to see any benefit on your farm other than feeling good about helping the environment. It's not going to increase your bottom line. It's going to reduce your land base for agriculture by a small percentage. But you'll be doing your part to reducing the nutrients that are coming off the farm. And there's not a lot of other technologies that would be as cost effective. So if the agricultural community were regulated to do it, in which case then you would see probably a very large uptake of these technologies, just because one, the construction cost is very small. If you have a backhoe shovel on one of your tractors, you can do it yourself as a farmer. So it's just your time and machine time. If not, then you're hiring, by the hour for a contractor. So it's not a serious expense. And the maintenance cost is the greatest benefit in that it's very, very low. You might have some berms to maintain depending on how you've controlled the water flow. And then you may want to maintain the side slopes depending on what species you have on them. But other than that, there's like very, very low maintenance and no chemical addition or ongoing costs. So if it comes down to comparing to other technologies, more mechanical technologies, the wetland systems will win hands down on a cost basis, on capital as well as operating. They take more space, so that's the disadvantage compared to like if you have a municipal wastewater treatment plant, but there's no way that we're going to have little municipal wastewater treatment plants running at the edge of each farm. I guess we were just talking one day and then and that they had this beef operation with a manure pile and an exercise yard. And it was kind of just running into this, I guess, ditch that wasn't really controlled in any meaningful way. So I talked to her about, well, maybe we could build a wetland. And then at the same time, we were interested in trying a vegetated filter afterwards, because the ministry has a guideline for vegetated filters where you basically distribute the water across a grass slope. So we thought if you put a wetland and a pond in front of it, you're going to take out all those solids. And then the vegetated filter, one, it won't clog with solids. And two, it'll very effectively infiltrate and deal with the rest of the nutrients. And you'll grow grass on it, which you're going to harvest for the feed for your cattle. So you can recycle the nutrients in the dissolved form very effectively with that idea. So that was the basis of it. So we developed the project, and it was a very effective demonstration project and a research study with exceptional results. Really, like the wetland itself. So it was like a classic initial pond for settling, followed by a very small wetland cell. I think it was maybe 10 by 15 meters, something like that. Not very large surface area. Followed by a second pond, which was an existing pond which we desludged that was on the farm already. So that alone was effective at removing, say, 80% of the nutrients and almost all the solids. And then the remaining nutrients that were in the dissolved form, they were taking out almost 100% what was left in the vegetative filter. And we actually did studies taking grass samples. My grad student, different before each cut. There's 3 cuts in the season, I think. She took grass samples, and we calculated the mass of the nutrients that was uptaken in the grass. So it's just a recycling of nitrogen and phosphorus very effectively. So you're looking at like close to like between 95 and 99% total removal of nitrogen and phosphorus, and basically effectively 100% of the organic matter and the solids in the system.